All right. I assume the end of the Muzak is my cue to start. My name is Sean McKenna. I am a PM in the Azure Compute team, and today we're going to talk about Cloud Foundry. I'm excited to be here at Ignite to talk about Cloud Foundry because I think it represents, having a Microsoft full-time employee on stage talking about Cloud Foundry really represents the change in Microsoft. And to illustrate that, we're going to play a little game. We're going to count the number of words that would have been scary to the old Microsoft in this description of Cloud Foundry. Okay, you ready? So this is a platform that's spun out of VMware, ding. Traditionally targeted Java developers, ding. Going after Linux, ding. It's open source, that's a ding. And enables you to go multi-cloud. I would say that's probably another ding. And so being able to be here on stage talking about Cloud Foundry, I think really is a great representation of the way that the company culture has changed. So that's who I am and why I'm here. I'm kind of curious why you're here. My assumption is that there's basically two groups of people in this room. One group is familiar with Cloud Foundry, has used it in the past, maybe in a different environment, and wants to learn about how it works with Azure. Does anybody kind of fall into that camp? Okay, a few people. And then the other half, I would assume, are people that have heard of Cloud Foundry. Maybe people are using it inside your organization. You've been tasked with going and figuring out what it is and how it works with the stuff that you're used to, and also kind of interested in how it would work on Azure. I assume that's kind of most people. Excellent. Okay, so that's kind of the way I oriented the presentation, which is I'm going to talk a little bit about what Cloud Foundry is and kind of what the platform is. And obviously, there's a ton of stuff to cover there, so it's going to be a little bit breezy. But I'm just going to try to hit some of the high points and some of the things that I think are particularly interesting about CF, potentially relative to some of the other offerings roughly in that space, and then also cover kind of how it looks on Azure and Azure Stack. So what is it? Well, at a high level, it's a cloud application platform. As I mentioned, it's an open source cloud application platform, particularly targeted at enterprise customers, and there's a few reasons for that we'll get into. As I mentioned, it is popular with customers that are looking to adopt a multi-cloud strategy and be able to run a consistent environment across a number of different clouds, including on-prem. It's available in a number of different forms, and we'll talk about that in a second with respect to the ways that you can run it on Azure. And like many open source projects, it's governed by a nonprofit foundation, the Cloud Foundry Foundation, which, as you can see, is made up of a bunch of little startups that are just kind of tinkering around. No, of course not. It's huge heavyweights in the industry that are behind Cloud Foundry as a platform, including, you may have noticed, Microsoft. So as of a couple of months ago, Microsoft is now a gold member of the Cloud Foundry Foundation. We announced that at the Cloud Foundry Summit back in June, which was really exciting. We've been working on Cloud Foundry on Azure for almost 3 years now. And so this was really just putting a bow on all of those investments that we've been making and really just kind of further reinforcing our commitment to the platform. So what does Cloud Foundry on Azure look like? What are the options? As I mentioned, Cloud Foundry is an open source platform. It's made up of a number of different projects. All of those are available on GitHub. You can go get those releases. You can build it yourself. We've got instructions on GitHub for how to get started. And so you can run that for free. Or at least you can, the platform part is free. You still pay for the VMs, obviously. And the great thing is that all of the integrations that I'm going to touch on today in terms of working with Azure work with that open source version. But of course, as is often the case with open source projects and enterprises, you want to have a phone number you can call if something goes wrong. You want to have some support and some additional tooling. And so there are a number of different commercial distributions available that come in different forms. So arguably the most mature of those is Pivotal Cloud Foundry. So we work closely with Pivotal as a partner to enable Pivotal Cloud Foundry on top of Azure. So that comes with enterprise support and a number of additional tools. And then more recently, we've added support for the SAP Cloud Platform, which is a hosted multi-tenant option, which allows you to run Cloud Foundry applications within SAP's cloud platform. So you sign up with an SAP account and deploy it through there, but you can choose Azure as a target. So I'm going to run through just a couple of things of what I think CF is cool. This is not some sort of like official list that you'll find on cloudfoundry.org. This is sort of Sean's list of why Cloud Foundry is interesting. And I think it's, I'm trying to position it sort of relative to some of the other things in that general space of cloud application platforms. So the first one is it's containerized by default. So unless you've been living under a rock in the enterprise IT world for the last couple of years, you're probably aware of containers. Kind of become a big thing. If you go to any of the Azure sessions, you're probably going to hear it ad nauseum. And what people think of nowadays when they think of containers is Docker, right? Where you're creating a Docker container image, you're building out a Docker file, you have that immutable image, and then you go and deploy that into an environment. And there's a lot of advantages to doing that, and in fact, you can deploy Docker images to Cloud Foundry. But in a lot of cases, you just want to think about your source code and just push your source code to your environment, but still be able to take advantage of some of the benefits that you get from containers in terms of having that immutable image with the application code as well as all of its dependencies, having resource isolation so that apps are not competing with each other for resources, and have a nice clean unit that you can use as a way to scale up and down. And so the nice thing with Cloud Foundry is you can get that without necessarily having to go through the process of building a container image up front. And the way you do that is by just calling CF push, and I'll show that in a second, where the application will actually get implicitly containerized for you. And so you still get a lot of the benefits of containers, but you don't necessarily have to go through the process of learning how to build them. So let's look at how that works. I was chatting with somebody outside. He said, don't save the demo till the end. You don't have to worry about that. There's going to be demos throughout. So I'm going to go over to the Azure Cloud Shell here. Never miss an opportunity to demo the Cloud Shell. And what I'm going to do is go into this CF apps directory, and I've got an app here called Spring Music. Hopefully you guys can see that. I'm using the large text setting. So this is just a sample Java application built with the Spring framework, which is, if people are not familiar, it's one of the more popular Java application frameworks, particularly targeted at building microservice applications. And so what I'm going to do is just CF push this application into Azure, and we'll sort of look at what steps are happening as that happens. So notice that I didn't have to build any kind of Docker file or manifest for the container. I was able to just say, here's my source code, push it up into Azure. And what's going to happen is it's going to go create an entry for that application. It's going to create a route for it. And so what that means is it's going to create a DNS endpoint within the Cloud Foundry router so that I'll have a publicly accessible endpoint to get to that application right away. So I'm not having to go in and fiddle with setting up some sort of DNS mapping for that application. And what's going to happen here, as you see as part of this staging process, is it's uploaded the files that make up that application, and it's looking at them using a tool called BuildPack, which is basically a set of scripts that will examine the source code, or in this case, it's looking at the jar file, since it's a Java application, and detecting what type of application it is and what its dependencies are. So in this case, it's detecting that it's a Java application, so it's going to go download a Java runtime environment, download a web server, and package all of that up into what Cloud Foundry calls a droplet, which is effectively a container, and then push that into the Cloud Foundry environment and start the application running. And so you can see it's started up here. And so if I just go grab this endpoint, there's my app. So literally with one command, I was able to take that application, push it into Azure, have an endpoint set up for it, and be able to hit it from the browser. And now if I go back here to the command line, I can look at the logs for that application. So there's all the logs that have been written to standard out, standard error. And I can also, as I mentioned, containers make for a great scaling unit, right? So by default, when I do CF push, it's going to create one instance of that application, but I can easily scale that out. Music. either scaling by adding more memory to that single instance, or more often doing horizontal scaling by adding additional instances. So in this case, I'll set it to 3 instances. And so now we'll see this first instance is the one that was pushed initially. That's up and running. The other 2 are still starting up. And the great thing about this is I mentioned that route that got created as the public endpoint for that application. That is a stable DNS entry that sits on top of these multiple instances of the application. So as I scale out to additional instances of this Spring Music app, the Cloud Foundry router will actually load balance the traffic incoming to that endpoint across these additional instances. So by now it's probably up and running. And so there I've got 3 instances. You'll notice that they have been constrained in terms of their resource allocation. So again, it's using a bunch of defaults here that you can configure. But the idea is you can constrain those applications, constrain those containers effectively so that they don't, you don't end up with sort of a noisy neighbor problem. Okay. And actually, just before I go back to the slides, in terms of, I know since people are new to Cloud Foundry, kind of wondering sort of how does this work in the context of Azure, just to kind of ground this a little bit. The way that you deploy this is a number of different ways, but the primary way that we recommend is going through the Azure Marketplace, where there's an entry for Pivotal Cloud Foundry. It gives you the ability to set up an installation in your Azure subscription. And I'm not sure why this Edge is being tricky, but you get the idea that there's basically a resource group within my Azure subscription that is storing all the different resources that are being used, IaaS resources that are being used to run my Cloud Foundry environment. So it's a bunch of VMs, virtual networks, disks, and so on. And so it's part of your subscription, but there's that sort of application layer that sits on top of it. Okay, so that was a Java application. I sort of alluded to the fact earlier that traditionally Cloud Foundry has sort of been most oriented towards Java applications. But more recently, they've been going after Windows apps as well. So I'll just briefly show what you can do with Windows. So I'm here in Visual Studio. I'm just going to create a traditional ASP.NET application. So not .NET Core, but probably something that you've got still running in your enterprises. And create an MVC ASP.NET application. And I'm going to push this using the same process into Azure. So I'm just using the ASP.NET template here, and I'll go ahead and build it. At the moment, there isn't really any deep integration with Visual Studio. That's something that we're working together with the CF community on to have the ability to publish directly from Visual Studio and do debugging and all that sort of thing. But for the moment, you can do it from the command line. There is a native Windows installer for the Cloud Foundry CLI, so you can set it up here in the command prompt. And if I go to the app that I just created, and CF push from here, so we'll call it Hello Windows Ignite. I have to give it, in this case, I have to give it a couple of hints about what I'm doing because it's running Windows, it's sort of the non-default OS, but if I tell it Windows 2012 R2, and then give it a hint about the build pack that it needs, which is the hosted web core build pack. That'll go ahead and do that same process that it did for the Java application, but now for this ASP.NET application. And the reason why I have to give it the hint about the hosted web core is that by default, the build pack will pick up and think that it's actually a .NET Core application and try to apply the .NET Core build pack. So you have to tell it that you actually want the sort of traditional ASP.NET hosted web core IIS package. But again, it's going to do that same process, create an endpoint for the application, bind that endpoint to the app. It's going to apply that build pack to pull in the necessary dependencies, start the app. And currently, this is targeting Windows Server 2012. Again, similar to Visual Studio, we're working with the CF community to enable Server 2016, in which case you'll get sort of full fidelity Windows Server containers. But at the moment, you can deploy to Server 2012. And there we go. The app has started up. And so same deal. I can just grab this URL. Over here. And I should get my ASP.NET template application. I think Edge is being funky here. Again, new Microsoft. We are willing to use any and all tools to get our demos to work. There we go. So there's the ASP.NET template application. So same process, same sort of operational model, and I can have basically the same environment, the same sort of Cloud Foundry environment for Linux applications as well as Windows applications. Okay. Second thing I think is cool is Cloud Foundry is really designed with a DevOps mindset in mind. So a lot of the best practices that have been distilled down by organizations building software for many years have been just incorporated directly into Cloud Foundry. So there's a few of those that I think are interesting, and in particular have integrations that we've done with Azure. So the first is the notion of a blue-green deployment, which people may or may not be familiar with, but generally the idea that I'll walk through in a second is you have sort of side-by-side versions of your applications, and then you redirect based on those routes that I talked about, and that's how you can do a no downtime upgrade. That's a first-class concept in Cloud Foundry, and I'll show that in a second. All of the application and system logs for the environment are automatically coalesced into a single stream that you can then pipe into whatever log storage solution you want to use. So we have a direct integration with OMS Log Analytics, but you can use Elk or Datadog or whatever tool you like. You don't have to configure any additional logging agent or set up something to get all of those logs coalesced. And then the third is Cloud Foundry is built on top of an infrastructure automation tool known as BOSH. And what BOSH does is manage all of the provisioning of the infrastructure resources as well as the software on top of those resources, and allows you to do sort of no downtime OS patching, for example, or upgrade of system components. And that BOSH layer provides a very strong consistency guarantee across different environments, a very strong abstraction, and that's what enables you to really run across multiple environments in a consistent way. So let me quickly walk through that notion of blue-green deployments, and then I'm going to show it here in VS Team Services. So the basic idea is I have V1 of my application, so consider like the Spring Music app or the ASP.NET app that I just pushed. And I get that route created that I can use to direct traffic through. But now I want to go and deploy a new version of that application, so V2 of that app. I'm initially going to create a route for that staging version, for that V2, that I can use to go and hit to do all of my testing against the V2 version of the app. But now at some point, I want to actually move over to the V2 and remove the V1, and I want to do that without any downtime for customers. And so the way this works in a blue-green deployment is I basically add an entry into that public endpoint, what you consider as the original sort of customer endpoint, to direct traffic to that V2. And a lot of times what you'll do is you'll have some split of the traffic between the two applications for some period of time. So either as part of a rollover, or in some cases, if you want to do like an A/B test, you can have just one version of the V2 application getting some traffic while most is still going to the V1. Once the V1 is no longer needed, then I can remove the route pointing to the V1 version of the application, at which point all of the traffic will start moving into V2, and I can remove the V1. And so this whole concept is directly built into Cloud Foundry. It's not something that you have to build a recipe for. It's sort of a first-class construct. And we've taken advantage of that with a plugin for VS Team Services that I will show here on my Mac. So another new Microsoft example, we're covering Windows, Mac, Linux, Windows Server, Java, .NET. It's kind of a whirlwind tour. Okay, so what I'm going to do is, here I've got the same Spring Music application that I showed earlier. And what I'm going to do is, if you recall, the V1 version of that app has this green banner at the top. So I'm demoing blue-green deployment, so obviously I'm going to change it to blue. And we'll see sort of how we roll through that blue-green deployment process using VSTS. So I'll just go in here and change the CSS. It's probably the only Azure session at Ignite where you'll see somebody in CSS. And I'm going to go ahead and commit that. Switch to blue. And push it. Don't push directly to master except in demo scenarios. But what's going to happen now is I've configured a webhook from my GitHub repo that is storing that sample application such that we should get a build started here shortly. There it goes. So this is all kind of vanilla VSTS, but it shows you sort of the end-to-end workflow, and we'll get to the Cloud Foundry specific part in a second. This is going to go ahead and do a Java build, get a jar file, push it up into an artifact repo that I can then use for a deployment. And once that's done, which it is, it'll trigger a release into my Cloud Foundry environment. So that's kicking off now. I go over here into logs. We'll start to see the, actually maybe I should zoom this in. Here, I'll just do this. You'll start to see the same type of output that we saw earlier from the command line, and that's because it's actually running, let's see here. Yeah. It's actually running the CF-CLI directly inside of VSTS. And the way that we've done that is, if I switch over to the release definition here, we've created a plugin for Cloud Foundry for VS Team Services. So basically, this just provides a VSTS UI wrapper around the CF-CLI, but I can configure all the things that I want in terms of that deployment, number of instances in memory, and so on, directly in here. And so as that release starts to roll out, what's going to happen is it's going to push that V2 of the application to a new endpoint, so to Spring Music staging. And then it's going to run some tests. It's going to run some basic tests. And then once those tests have passed, it'll add a route from the V1 version, or sorry, from the sort of public endpoint to the V2. So now we'll have a split across the V1 and V2 of the application. So if I look at Spring Music staging, we should see the blue header. There we go. And then if I go to the main Spring Music, we'll see, as I refresh, we'll see a mixture of the blue and the green. And you'll see, typically, because if you remember, I scaled up the V1 of the application to 3 instances, so you'll expect to see about 25% of the time hitting the blue version and the rest going to the green. So yeah, you'll see green coming up most often, but that initial time it was blue. And now, if I go back to Team Services here, where is it? I've got it configured so that in the middle of that deployment, when I'm in this kind of halfway stage where I've got the route pointing to both the V1 and the V2, I actually have it pause. And so you imagine that I've got some of that traffic coming in, 25% of the traffic coming into the V2 of the application. I'm analyzing my telemetry, looking at user forums, all that kind of stuff. If everything looks good, then I can go in here and just say ship V2. And then that'll proceed along the rest of the deployment, which will basically do what I showed in the slide, which is, the STS is being funky today. Remove the route from the old app, so remove the route from that V1, and then delete the old app and unmap the staging route. So at that point now, that public user endpoint should be exclusively pointing to the V2, so the blue version. Actually, let me force that refresh. There we go. And so no matter how many times I refresh now, I'll just get the blue version. So that whole notion of mapping routes to, or separating out the notion of the DNS endpoint from the underlying application allows you to do these really easy blue-green deployments. Okay. The third thing that I think is interesting about CF is it's really built for the enterprise. And I sort of alluded to this earlier. I'm going to dig into a little bit more about why that is. One of the first-class constructs that are provided within the CF platform is the notion of an organization. And so oftentimes what we find with large enterprises is you have your centralized IT department. They want to have some sort of control over the procurement and the environment. But you still want to give individual organizations within the enterprise control to be able to ship their own applications at their own pace and really adopt a sort of agile delivery mechanism. And so CF really handles that well by allowing you to have these large Cloud Foundry environments that then get segmented down into individual organizations. And each of those organizations can have their own access control and resource allocation, and you can really set it up based on what that organization needs. The second thing is Cloud Foundry provides the notion of a service broker, which is effectively a way to provide a catalog to application developers of all the different types of backing services that they can create for their applications. So if you think traditionally of the way that you would have to get a database to back your application, you might have to file a ticket and get operations to go and create that database for you and then somehow provide back the credentials to you, and that whole process was quite heavyweight. The service broker provides a clean, consistent way to both provision those backing services as well as bind to them. So get the necessary endpoints, connection strings, credentials back into the application. And that service broker concept works hand in hand with the organizational concept, so you can actually define what different organizations can use in terms of those backing services. So what we've done for Azure is build the Azure Service Broker, which I'll just briefly show here, since like many other things these days, it's open source. So the Azure Service Broker is effectively a Cloud Foundry application in and of itself that you deploy into your environment, and it gives you access to all of these Azure data backing services, and we're adding more to this list every day. But what I'm going to do is show a quick demo of kind of how this works. And first, what I'm going to talk about is how this works in the context of this organizational concept that I mentioned. So I'm in this console window, in this command line, I'm actually in an administrator view. So imagine that I'm sort of the operator of the entire environment. And here I can look at, using CF Service Access, the set of services that I have deployed, or service brokers that I have deployed in my environment. So in this case, I just have the Azure Service Broker, and you can see all the different services that we provide as well as the individual plans. And this would line up to what you would see in the Azure portal. But what you'll notice here is while most of them are available to everyone, a couple of them, particularly the Azure SQL, I, as the administrator, have limited in terms of which organizations can use those. So as is always the case, finance and marketing have all the budget, so they get to play with the fancy toys. Engineering is left to use the standard and basic SKUs. But if I go back now to what you can think of as a developer view, I can call effectively the developer side equivalent of that command, which is CF Marketplace, and see the set of backing services that are available to me as a developer. And if we look at the SQLDB example here, you'll notice that all the basic and standard SKUs are available as well as the data warehouse, but I don't see the premium ones. And that's because the administrator has locked down and not allowed me to actually provision the premium SKUs. And so this provides a lot of power for administrators to choose what individual organizations can run or what they can create, but also putting power in the hands of the individual organizations in the sense that, okay, I put you in the sandbox of what you can use, but now you have the capability to go and provision and bind those services. So let's take a look at how this actually works. So I've got a Node.js application that depends on a Redis cache. Doesn't really care where it gets that Redis cache from, but it needs a Redis cache to actually run. And so what I'm going to do is use the Azure Service Broker to create that Redis cache and then bind it into my application. So I'll do CF create service, add Azure Redis cache. I have to give it the plan that I want to use, which in this case is basic, because I'm going to save a few bucks. And then I need to give it a name. So we'll just call it Ignite Redis. And that's going to go ahead through the service broker and start provisioning that service. And you'll notice the create is in progress. And in fact, if we jump over to, where's my Azure portal here? The Azure portal, under this Azure Service Broker resource group, we now have a fourth one that's starting to spin up. Not that one. Well, one of these is in the creating state. So that's brokered into Azure to actually to spin up that service. And now the second half of the service broker is actually getting the credentials from that service. In the case of Redis, I've got an endpoint and a key that I need to be able to connect to that Redis service. And so that's going to happen as part of the CF push. And because the Redis cache takes a few minutes to start up, I'm just going to use an existing one. But I'll do CF push. Let's see, Ignite Redis. Actually, no, it's in the manifest. Let's just take a quick look at the manifest here. So this is the Cloud Foundry manifest. Allows you to specify some of the values to override some of the defaults. You'll notice this services item here with Ignite Demo. That's one of the services, the Redis cache services that I had already spun up. So if I just CF push that, we'll see this familiar by now process, which is going to go ahead and push that application into Azure and do a bind to, you'll notice right here, binding service, Ignite Demo to CF Redis Demo. And so that binding process is, again, bringing the endpoint and as well as the credentials into the application by an environment variable, which, in fact, if I switch over here, what did I call this again? CF Redis Demo, and do CF end CF Redis Demo, I can see the environment variables for this application, and you'll see here the credentials that are being passed. So that application, the Node.js application, is literally looking for this environment variable to be able to get these credentials, and then from there it can talk to the Redis cache backend. And assuming that that deployment has completed, it has. Go grab this endpoint. And so here I can just store key value pairs and get them back. And that's being stored in that Redis cache. Right. There you go. So I'm also available for web design. I do that a little bit on the side if you guys are interested, if you're impressed. So the key thing to keep in mind with the service broker, well, two things. One, you might wonder, like, why wouldn't I just go to the Azure portal or use the Azure CLI to do that provisioning? Well, for one thing, it's providing a consistent model across all the different types of backing services that I might want to use. So I could actually deploy, like, the AWS service broker into my Azure environment and be able to get AWS services backing my applications and use that same consistent command line interface and model. It's also providing those credentials in securely, so I'm not having to worry about where those things are being stored and having them sit around in configuration files because they're just being injected as part of the push process. The other thing to note is that basically once that binding has happened, there's no proxying. The service broker is not involved in the actual communication between the application and the backing service. It's just a matter of getting the necessary credentials to it so that it can then talk using just the REST APIs or whatever SDK. Like at that point, the service broker is not involved at all. There's no sort of Cloud Foundry piece left in it. Okay, so that's kind of the breezy top-level things that I think are interesting about Cloud Foundry. As I mentioned, there's kind of lots of different elements to it, lots of power in the platform, but those are some of the things that I think are particularly compelling. So let me touch a little bit on why I think Cloud Foundry on Azure is interesting. As you might expect, we make a lot of noise about our global footprint. We have more regions than our two major cloud provider competitors combined, and we have Cloud Foundry available in all of those geos, in all of those regions. More interestingly, we have it available in all the different sovereign clouds. So not only the Azure public cloud, but also Azure China, Azure Germany, and Azure government. And it's not actually a theoretical possibility. We have customers deployed in production in all of those environments. So we have customers taking advantage of the availability of Cloud Foundry in all of these different Azure clouds. I touched on a few of the integrations with Azure services. There's a few more that I didn't talk about before. Cloud Foundry has a set of system databases that manage like the users as well as the application metadata. We now have integration for those system databases to actually be managed inside of our MySQL or Postgres managed database services. So whereas traditionally you would run them directly inside the Cloud Foundry environment on IaaS VMs, you can now move that data off into the managed service, which takes another kind of operational headache off of your plate. You can also now use the Azure Application Gateway as the layer 7 load balancer and ingress point if you want to do SSL offloading at the app gateway layer. We now have integration with Cloud Foundry for that. Then a question that often comes up is around customer support. Again, because this is something that's, it's not a branded Microsoft service, it's an open source platform that we're running on Azure. There's two things to note there. One, Azure CSS, Microsoft CSS has received training in Cloud Foundry, so they have basic sort of diagnostic troubleshooting skills with Cloud Foundry. They won't answer the phone and say, what's a Cloud Foundry? We can at least assure you of that. But as I mentioned before, if you're looking for enterprise support for the platform, that's where we would suggest to adopt one of the commercial distributions, like a Pivotal Cloud Foundry. And if you do go with PCF, we do have a joint support agreement with Pivotal so that the two support teams will work together to resolve your issue and figure out exactly where it is, whether it lies sort of on the Cloud Foundry side or on the Azure side, and make sure that we get to a resolution. So let me talk briefly about Azure Stack in the context of Cloud Foundry. So I was actually going to try to squeeze in an Azure Stack demo, but then I realized it wasn't really going to be that interesting because it was going to look exactly the same. So the basic idea is what we've built to enable Cloud Foundry to run on the Azure public cloud is this thing called the CPI, the Cloud Provider Interface, which plugs into that Bosch tool that I referred to earlier, which is, again, the infrastructure automation tool that does all of the provisioning of VMs and attaching of disks and creating of networks and all of that kind of stuff. And so what we've done is basically take that Bosch CPI and put it on top of Azure Stack. And with a few little tweaks here and there, it now basically works. And so that's what's going to enable you to run Cloud Foundry on top of Azure Stack and get that consistent environment across both the edge with Stack as well as with public cloud. In the near term, and this is what the box on the right is, there's some work that we have to do to actually enable the service broker to work with the individual services, the backing services on Azure Stack. So for the near term, if you want to use the Azure Service Broker, that's still going to provision backing services in the Azure Public Cloud. And so that's just the one kind of caveat to keep in mind is that you wouldn't have full isolation within Azure Stack. You would be sort of calling out to the public cloud for those backing services. But again, as I mentioned here, the service broker is optional. You can obviously just use everything running inside of Stack. Let me briefly touch on a customer example because it kind of ties into some of the things that I've been talking about. So Merrill Corporation is about a 50-year-old company that does financial content management. So think of like SEC filings, mergers and acquisitions, reporting and content sharing. And they were looking to transform the way that they were building software. They're primarily a Java shop. So they adopted the Spring Boot and Spring Cloud Services frameworks. As I mentioned earlier, those are some of the popular frameworks for building Java microservices. And they're leveraging a number of the Azure backing services, so Azure Blob and Key Vault and AD for authentication. And then what's really interesting is I mentioned we've got customers running in production in all the different sovereign clouds. Merrill is one of those. They had a strategic business need to go into Germany. They'd already built out their application running on Cloud Foundry on Azure in the public cloud, and they wanted to go to Germany in a matter of a couple of months. It took them about 2 weeks to be able to basically take their Cloud Foundry environment and all the applications that they built with Spring and using all of these Azure backing services and be able to deploy into the Azure Germany sovereign cloud and take advantage of all of the data protections that we provide there. So this is a great example of a customer being able to leverage that global footprint and the consistency that they get from Azure and Cloud Foundry. So let me wrap up with a little bit on roadmap and some of the things that are coming soon. You may have seen we announced last week that Azure will be adding support for availability zones. So as an additional availability construct and disaster recovery tool. So we'll provide support. In fact, Cloud Foundry is going to be one of the first platforms that integrates that availability zone construct. We'll continue to expand that service broker. Our intention, our aspiration is to provide every Azure service through that broker. The ones that we have queued up in the near term are HD Insight, Data Lake, and Azure ML. But this is really a customer-driven prioritization exercise. Everything's ultimately a customer-driven prioritization exercise, but this one in particular, if you have a specific Azure service that you would love to leverage through the service broker, please get in touch and we can talk about moving that up the list. As I mentioned, we're working with Pivotal in the CF community to provide Visual Studio integration, which will be great, allow you to do kind of what you expect to do with Visual Studio and building .NET applications, doing publish directly from VS, doing deployments and debugging. And we're also working on enabling Server 2016 support, so you'll get those Windows Server containers. And finally, I mentioned the application and system logs that you can push off into OMS Log Analytics today. Eventually, what we'll enable is to move the application telemetry, so the application metrics, into App Insights. So you have sort of the system information in OMS and the application data in App Insights. So you can really take advantage of the best of both tools. Here's a bunch of resources to get started. As I sort of alluded to earlier, the fastest way to get started is using the Pivotal Cloud Foundry entry in the Azure Marketplace. You can get up and running in a couple hours. Well, the setup time takes 2 minutes, and then the part that you have to deal with is 2 minutes, and then the actual provisioning takes a couple hours, but then you'll have a full environment that's got all of these integration points already built in, and you can go ahead and do all the demos that I talked about today. One thing I'll point out here that I didn't go into is the Steel Toe project. I mentioned the Spring Framework as tools that you can use to build Java microservices. Steel Toe is a project to provide a lot of those same capabilities for .NET applications. So a lot of the microservice patterns that have actually been developed by primarily by Netflix. So Netflix has released a bunch of tools for building microservices. The CF community is taking a bunch of those patterns and building them into .NET libraries, and that's what Steel Toe enables. So with that, I'll say thanks very much. Enjoy the rest of Ignite, and I'll be around for questions. Oh, and fill out your evaluations. I need to remind people of that.